Well, welcome back to another lesson in our series. Tonight we're focusing again on complex numbers, also known as imaginary numbers. So let's start with a graph of f of x equals x squared and identify the x-intercepts. Okay, so hopefully you can picture this in your head, and let's get a sketch in our notebook here. X squared, we should all know, is a quadratic. The squared implies the quadratic, and the shape that it makes is called a parabola. Notice there's no vertical or horizontal shift, so we know it's centered right at the origin is where our vertex will sit. And we have a nice parabola, okay, a quadratic function. And again, that x squared implies quadratic. Then it says identify the x-intercepts. Well, I would say there is one x-intercept, and we'll call that point 0, 0 at the origin. Again, another name for this x-intercept would be a 0. Part 2. On the same set of axes, sketch f of x equals x squared plus 2 and identify the x-intercepts. Okay, so just think about, it's a very similar graph. Notice it's x squared, so it's still a quadratic. This 2, though, is shifting your graph where? Hopefully you said it's shifting the whole function up 2. So I'm going to go up 2, and again I'm going to make my quadratic or my parabola. Now look at this. Identify the x-intercepts. Well, does this graph have any x-intercepts? Does this parabola ever going to hit the x-axis? No. This is going up to infinity. As x approaches infinity, f of x approaches infinity. And as f of x approaches negative infinity, f of x is approaching infinity. It will never hit the x-axis. So let's make a note that it has no x-intercepts. Now, why is that so important? Well, when a graph has no x-intercepts, it doesn't have any real solutions. Therefore, it has imaginary solutions. And let's go ahead and make a big deal about that. Okay, since I have no x-intercepts, my solutions are imaginary. Okay, I have no real values where I cross the x-axis. So in our previous video, we talked about the definition of the imaginary number I. And let's just review that for ourselves. So this is something we probably want to box in our notes here. The definition of an imaginary number is the square root of -1 is equal to I. We then said, remember, if we square both sides, I squared is equivalent to 1. Just as a little reminder. But the big definition here is that the square root of -1 is equal to I. So let's get some practice simplifying each of the following. Number 1, the square root of -9. Well, up until yesterday, we weren't allowed to do this. Now we can. We can really break it down as the square root of 9 and the square root of -1. And we know that the square root of 9 is 3. And we now know the square root of -1 is I. So the square root of -9 is 3I. All right, let's try 18. The square root of -18, I mean. So I can take the square root of 9 times the square root of 2 times the square root of -1. Notice I needed 3 numbers that multiply to -18 here. The square root of 9 is 3. I don't know the square root of 2, so I'm going to leave that. And the square root of -1 becomes that I. So 3I radical 2. All right, now we'll make them a little more interesting. We're going to leave the -4, and I'm going to break 8 down as 4 times 2. That gets me a +8 times a -1 to get me that -8. Again, I'm going to leave the -4. The square root of 4 becomes the number 2. Now notice, there's no plus sign here, so you're not adding. When terms are next to each other, we're multiplying. So that's going to be -4 times 2 times the square root of 2 times an I. And it's just proper to bring that I out in front, so I'm going to call it -8I radical 2. And lastly, notice we have a fraction here, so don't let that scare you. Again, I'm just going to break it down the way it is. I'm going to say it's the square root of 25 times 2 times -1 all over 4. And then just ask myself what I know. So this is 2, that becomes a 5, so times 5 times the square root of 2 times I. So I think we can call that 10I radical 2. And don't forget that's all sitting over 4 from this fraction here. And then I can simplify the numbers out front. They're both divisible by 2. So 5i radical 2 all over 2. Okay, the next piece says solve each of the following. So A, 5x squared plus 8 equals negative 12. So I need to solve for x. So my goal is to get that x by itself because there's only one x. Okay, so the first thing I'm going to do is I'm going to subtract over that 8. So I've got 5x squared equals negative 20. I'm going to divide by 5, so I'll divide that out, divide this out. I get x squared equals negative 4. And then to get rid of a square, hopefully you're saying in your head, take the square root. Now notice, because you're taking the square root of both sides, you do include the plus and minus. So now I would say x equals plus and minus. The square root of 4 is 2, and the square root of negative becomes I. So x equals plus or minus 2i. So remember, that's really two answers. That's positive 2i and negative 2i. Let's give another one a whirl. 2x squared minus 10 equals negative 36. So hopefully you're saying you can simply add over that 10. So 2x squared equals negative 26. Divide by 2, x squared equals negative 13. Take that square root of both sides, don't forget your plus minus. So x equals plus or minus the square root of negative 13. Now would you agree you can't break 13 down? But you can pull out an I. So I would say that's I radical 13. And again, where does that I come from? Well, it's imaginary because there's a negative under the square root. All right, last one. 1/2 x squared plus 20 equals 2. So I'm going to leave my 1/2 x squared. I'm going to subtract my 20, so that's going to get me a negative 18. Now I think of this as maybe like cross multiplying. I would say this is x squared over 2, if I were to multiply those, equals negative 18. Basically, I'm saying 1's on top, 2's on the bottom, and this is like x squared over 1. So x squared's on top and 1's on the bottom. I can multiply, put that over 1, cross multiply. So x squared equals negative 36. Take that square root. We're going to get an imaginary number because of that negative under there. So I'm going to say plus or minus 6, and then don't forget the I. All right, now into the big part of the lesson. These are called powers of I. And to help memorize them, we call it the cycle of 4. All right, so the reason I say cycles is because I kind of draw it in a circle, and cycle of 4, there's 4 of them. So I'm going to start at the top of the cycle, and that is I to the 0. We're going to come around, and we're going to say I to the first. Come around, we'll call this one I squared. Come back to here, I cubed, and it just repeats in this cycle. So it just keeps going around the circle, basically. And again, I call it the cycle of 4 because there are 4 of them. All right, now you should already know actually 3 of these 4 answers. So think about this. Here's the one we've talked about the other day. I squared is equivalent to negative 1. Okay, I to the first is a nice one because what's anybody to the first power? Well, that's just simply I. Itself, basically. 10 to the first is 10, 5 to the first is 5, I to the first is I. Another nice one you should know is I to the 0. Anybody raised to the 0 is equivalent to 1. 10 to the 0 is 1, 5 to the 0 is 1, I to the 0 is 1. Now the one you probably shouldn't know, but you'll learn right now, is I cubed, and that's equivalent to negative I. Now, if you remember the cycle of 4 and you start at 0, there's kind of a neat little pattern here. Notice 1 is across from negative 1. I is across from negative I. So as long as you get these two down in the cycle, it's very simple. This is across from its negative, and this one's across from its negative. And it just starts at 0. 0, 1, 2, and 3 complete the cycle of 4. So So what type of questions might you have to answer with this? Well, perhaps they'll ask you, what is, we'll call this question A here, 5i cubed? Well, you'll have to know that I cubed, based off the cycle of 4, is equivalent to negative I. So this is really 5 times negative I. So this answer is negative 5i. When if we said 3i squared? Well, we'll have to know that that means 3 times negative 1. I squared is equivalent to negative 1, which is equal to negative 3. Now, it gets a little more intense. So let's make a big note to ourselves. Okay? If the exponent is greater than 3, here's what you do. You divide, but you use the remainder. So we'll go through a few examples. So if the exponent's greater than 3, you divide, but you use the remainder. So let me show you an example of how I am interpreting this. Let's say I say x to the 14th. I'm sorry, I to the 14th. Okay, so basically I need a number to be in my cycle of 4. I either need I to the 0, I to the 1st, I squared, or I cubed. Okay, those are the only 4 that I know. I to the 14th, I don't know. So here's what you do. You just divide. It's called a cycle of 4, so you divide by 4. And you basically just use long division, and we're pretty darn good at that by now. 4 goes into 14. I'm going to say 3 times. 4 times 3 is 12. Wrap it up, subtract. 14 minus 12 is 2. So the remainder is 2. So look how simple. I to the 14th then is equivalent to I squared. Use the remainder. And now we know from our cycle of 4, I squared is equivalent to negative 1. All right, we'll practice a few more. Let's say I to the 28th power. Okay, so the rule says if it's greater than somebody in the cycle of 4, you take that exponent and you divide by the cycle of 4. Okay, 7 times 4 is 28. Okay, but we don't care about the 7, we care about the remainder. What is 28 minus 28? 0. And that's the number you use. So I to the 28th is equivalent to I to the 0. And that's easy. Don't even look at the circle. What's anybody to the 0 power? 1. And there we go. We just broke down I to the 28th. Okay, let's try another one. 5i to the, let's say 16th. 16th. 5i to the 16th. Okay, so I'm going to leave the 5. And I'm going to put an I, but I know I need to change the exponent. So I'm saying 16 divided by the cycle of 4. 4 by 4 is 16. Subtract, and I get a remainder of 0. So that's the same thing as 5i to the 0, which is really 5 times anybody to the 0 is 1, which is just 5. All right, one last one for you to try on your own. Let's say 2i to the 15th. All right, pause it, give it a whirl, and then turn it back on to see if you got it right. All right, so I took that exponent of 15 divided by 4, went in 3 times, but all I care about is that remainder. So I said 2i to the 15th is the same as 2i cubed, and I cubed is negative I. So this final answer is negative 2i. All right, I'm going to squeeze one more down here. Let's say I squared times I cubed times I to the 4th. All right, so think about this. When you multiply, think of like x times x. What do you do with the exponents? Remember, you add them. So I squared times I cubed times I to the fourth is actually I to the 4, 7, 8, 9. Okay, and then again, all you got to do is break it down. 9 divided by 4 is 2. 4 times 2 is 8. That gives me a remainder of 1. So I get I to the first, which just happens to be I. All right, in the next little set, it says find the product. And obviously product means multiply. So I've got the outside, 4 times 6 is 24. And when you multiply, what do you do with exponents? If you don't remember, make a little note for yourself. When you multiply, you add exponents. So this is 24, I to the 15th. Now again, you might be thinking you're done. There's just one more step. You just have to have somebody in the cycle of 4. So we have to break 15 down. So off to the side, 15 divided by the cycle of 4. Let's see, 4 times 3 is 12. Subtract, I get a remainder of 3. So this is really 24, I to the third. Okay, and if you don't have that cycle drawn out for yourself, get it there. I to the 0, I to the first, I squared, I cubed. And I cubed is equivalent to negative I. So I would say this is equivalent to negative 24I. All right, let's try one more. Find the product. Now this one's a tad different. Notice you're not just multiplying the front terms and the I terms. You've got two binomials. How do we know that? There's a plus or minus sign between them. So you need to slow down and FOIL. So this is going to get me 6I to the 5th minus 12I to the 6th. Let's see, plus 12I to the 8th minus 24I to the 9th. And again, you're just not done there until you apply the cycle of 4. So I'm going to start with this exponent. 4 divided by 5. 4 goes in there once. That gives me a 4 and a remainder of 1. So this is really 6I to the first. 6. Can you do it in your head? 4 goes into 6 once. How much is left over? 2. Good. So 12I squared plus 12I to the what? If you got to write it down, go for it, but I'm going to try to do it in my head. 4 goes into 8 twice, but I don't care about that. How much is left over? 0. The remainder is 0. Minus 24I. 4 goes into 9 twice. That gets me an 8. And the remainder, the difference from 9 and 8 is 1. Okay, so now I just have to put any like terms together and clean up anything I have. This is just a 6I. Here, I squared turns into negative 1, so that's really negative 12 times negative 1, which gets me a positive 12. Anybody to the 0 is the number 1, so that's really 12 times 1, which is just 12. And I to the first is just I, so minus 24I. Again, like terms, 6 minus 24 is negative 18I, and 12 plus 12 is 24. Our very final piece tonight is on rationalizing the denominator. Now we did with this radicals. We said we couldn't leave radicals in the denominator, and the same goes for imaginary numbers. We don't leave imaginary numbers in the denominator. So let's take a look at a real easy one. 4 divided by 3I. Okay, so like I just said, you can't leave an I in the denominator. So we're going to multiply the top and bottom by 3I. So on top I get 12I, and on the bottom 3 times 3 is 9, but be careful, I times I is I squared. Now remember, you can't have an I on the bottom, so it should cancel out. What do you know about I squared? Well, I squared is equivalent to negative 1. So I actually get 12I over negative 9. Now I can reduce this because these numbers are both divisible by 3. So 4I divided by negative 3. Okay, so I didn't make a note here, so perhaps you should make a note to yourself. You cannot leave I in the denominator. Okay, so this is called rationalizing the denominator. You cannot leave an I there. All right, let's try another one. 3 plus 4I divided by 2 minus 5I. Now this one's slightly different. Notice we had monomials in the first one. Now I have a binomial. So I can't leave I in the denominator, and remember we did this with radicals. Again, we're going to rationalize it. We're going to multiply by the conjugate when there's a binomial. So 2 plus 5i to the bottom. Whatever you do there, you have to do to this top, 2 plus 5i. So just be real careful with your FOIL. 3 times 2 is 6, plus 15i, plus 8i, plus 20. I times I is I squared. On the bottom, okay, FOIL again, 2 times 2 is 4. Because these are conjugates, what happens to your middle term? Hopefully you know they cancel. If not, write them out for yourself. Lastly, am I going to get a positive or a negative? Hopefully a negative. 5 times 5 is 25. I times I is I squared. Now remember, we're not done until we've cleaned up our cycle of 4. So I have 6 plus 15 and 8. So that's going to get me a 23i. Now remember, this term is actually positive 20 times I squared is negative 1. So that gets me a negative 20. And again, I can combine the 6 and the negative 20 to get me a negative 14 plus 23i. Now I'll clean up that denominator. I have 4 minus 25 times I squared is really negative 1. So that really gets me 4 plus 25. So I can say divided by 29. Okay? Now, the same goes. If there's a GCF, we want to factor the top, and then I can cancel with the bottom. But notice there's no GCF here. Well, hopefully that's enough practice, and we'll get a quite bit more of that in class tomorrow. If you have any questions, feel free to stop by before class, and have a great night.